We present EmBARDiment, an embodied LLM agent for productivity. Large language models, while commonly used in chatbots, hold potential to power a wide range of XR agents. However, as of now, prompt generation failed to utilize the full suite of natural inputs available, especially so in XR, where we have access to inward-facing sensor data. We propose a solution that derives context implicitly from eye gaze. We implemented an interactive multi-window workspace. We extend the workspace to select what the user is reading so that instead of this,
Can you give me an idea for this competition?
Could you give me more information about the competition?
we can have this.
Can you give me an idea for this competition?
How about creating a doodle that envisions a world where education is fully immersive? With students learning through interactive holograms, your doodle could illustrate children around the globe.
This minimizes the need for engineered explicit prompts, fostering highly contextual interactions that glean user insights for the chatbot. Parameter tuning depends on the scene's textual density and uniformity.
What do you think about what I'm reading?
You're engaging with some deep financial topics, from the state of the U.S. economy to global trade dynamics. Your reading material is quite thought-provoking, delving into China's strategy in global trade and its implications for international relations.
In this second part, due to the eye-tracking specific selection, the answer is more specific. Selection granularity can range from single words to full screen's contextual memory. Word count thresholds can also be varied. We set to evaluate our system. Our evaluation aims to determine the merit of visual attention as a method of selecting contextual informations, with the final goal of supporting implicit communication with the agent. To do so, we need three conditions. First, a baseline in which there is no contextual information added. A condition where all the contextual information are selected independently from the user visual attention. And finally, the condition which selects informations based on eye tracking data. We then designed an experiment aimed to assess how effectively each of the three conditions support implicit communication. Participants will be requested to read a text on a multi-window setup consisting of 3 windows. For each window they ask to previously memorize implicit question to the AI agent. And if the AI agent's response is not contextually relevant and accurate, the participant will attempt to reformulate the question up to 5 times in order to reach an acceptable answer. During the reformulation, participants will be allowed to add any novel information they deem necessary. Now I will show you a video of single question on the baseline condition.
Why is it 50%?
The 50% you mentioned isn't clear in this context. Could you provide more details or clarify what you're referring to?
Why is a 50% chance of decaying?
A 50% chance of decay typically refers to
What about in the context of Schrodinger's cat experiment?
in Schrodinger's catbot experiment, a 50% chance of decay refers to a quantum event that determines if the cat is alive or dead.
Why is it set to 50%?
The 50% chance of decay is crucial because it creates a superposition where the cat is both alive and dead until observed.
Results. We started our analysis by looking at the variance of the number of attempts per participant across conditions. This plot shows the average number of attempts per participant across conditions. Lowest numbers are better as they indicate less attempts and therefore less effort to reach the acceptable question. We can see significant difference across all 3 conditions. Notably, the eye tracking condition outperformed others, requiring fewer attempts, as did the full context condition when compared to the baseline. We further unpack the results with this plot that shows the success rate at each attempt. In the eye tracking condition, over 90% of participants achieved the intended result on the second attempt. In the full context condition, over 90% succeeded by the 4th attempt. In contrast, in the baseline condition, over 90% of participants reached a satisfactory result only by the 5th attempt. Finally, in the eye tracking, all participants found satisfactory answers. but in the full context and baseline condition, not everyone did. Our initial aim was to assess how effectively each condition enabled implicit communication. Our results show that in the eye-tracking condition, the preformulated implicit questions led to successful answers, while in the other two conditions, participants had to reformulate the question multiple times and in some cases never reached the answer. To better characterize the user experience beyond the quantitative analysis of the attempts, we asked participants to rate the helpfulness of the system for each condition. Participant could answer on a scale 1 to 5, which in the plot translate in blue very helpful and red very unhelpful. Results show that participants found the eye-tracking condition significantly more helpful compared to the full context and baseline condition. Showing consistency with the results from our quantitative analysis, we also asked participants to rate their satisfaction with the answer received on a scale 1 to 5, which blue very satisfied and red for very unsatisfied. So the results show that participants found the eye-tracking condition significantly more satisfying compared to the baseline condition. Once again, this results show consistency with the quantitative analysis. Another aspect that we examined is related to the embodiment and position of the avatar. We asked, how do you prefer the visual representation of a digital assistant to be designed? For this question, we show participants three options: lack of embodiment, non-anthropomorphic, anthropomorphic. Participants were shown each of the condition in the VR environment and asked to choose the one they preferred. The option that received the most preferences is anthropomorphic, followed by non-anthropomorphic and lack of embodiment. When asked to justify their preference towards anthropomorphic, participant mentioned a desire for interactions that mimic human communication. Although many preferred an anthropomorphic design, they were flexible about the representation, as long as it was visually present. Those that choose lack of embodiment valued lack of representation as it is non-distracting or visually imposing. For our second question, we asked participants, where do you prefer the AI assistant to be located? Giving them two choices: context following or fixed. After showing these options to participants and addressing any questions, they were asked to make a choice. Most participants preferred context following, but around 1/3 opted for fixed. Those that prefer context following valued an accessible agent which can be seen without turning their head to the fixed location on the side. In general, user highlighted how the avatar location seemed to represented the information the avatar has access to. Future explorations could involve mapping outputs through both visual and auditory channels.
Based on Tom's emails, which materials works best?
Based on Tom's minimum criteria, the materials that meet these requirements are polycarbonate and nylon. I've highlighted the two options.
Could you type an email response to Tom telling him that the chosen material is nylon?
Yes, I will type a response based on the identified best material.
An open source version of the project is available on the display website. Thank you for your attention. We look forward to answering your questions.